Welcome, Math 252. We're looking at problem 28 from section 5 for the Hughes-Howard text. We're supposed to find the integral from 2 to 5 of this function f of x, and we're given that f of x is odd, and that the integral from minus 2 to 5 of f of x is equal to 8. So let's look at some facts we're going to need to get this problem done. First thing we need to know is one of the important facts from this section. If you have a continuous function f and any three numbers a, b, and c, then when you integrate your function f from a to b, what you get is the sum of the integral from a to c of f and the integral from c to b of f. It does not matter what these three numbers are, it always works. That's a useful fact. The other thing we need to know from this section, which is occasionally useful, is that if we have an odd function, a continuous function, so we can integrate it, and if we have any number a, then if we integrate from minus a to a of f of x, we're going to get 0. And that's because the area on the one side is going to be below the x-axis, and the area on the other side will be above the x-axis. They'll cancel each other out. We're getting that from the fact that it's odd. So in this particular case, we've been given that 8 is the integral from minus 2 to 5 of f of x dx. And we use the addition property of the integral to write that as two integrals. We write it as the integral from minus 2 to 2 of f of x plus the integral from 2 to 5 of f of x. And then we use the fact that we've been told that f of x is odd to evaluate that first integral, the one from minus 2 to 2, and see that it must be 0. And that tells us that, in fact, the integral from 2 to 5 of f of x dx has to be 8.